Okay, so today we are solving compound inequalities, which means that we are solving two inequalities in one, essentially. So give one number that works for each description. If there is no number that fulfills the requirements, say so. So numbers that are greater than 7, or I'm sorry, less than 7 would be like 6, 5, 4, 3, 2, 1, and greater than 4. So greater than 4 would be like 5, 6, something like that. So if you picked anything like 5, 6, 6.5, anything like that, that would work. Greater than -1 but less than 0, so that means between -1 and 0, so you would have to pick a fraction or a decimal for this one. -1/2 would work nicely, or any other numbers in between there. Greater than 7 or less than 4. So notice the difference. This says and, this says and, so the number has to meet both requirements. However, this one says or, so as long as it meets one or the other, you're fine. So a number greater than 7 would be 10, a number less than 4 would be 3. So both of those numbers would work for this compound inequality that is an or statement. Less than -1 and greater than 0, so it has to meet both requirements. If it's less than -1, it's more negative, so -2, -3, -4. Greater than 0 is all positive numbers, so this is not possible, or no solution, however you want to say it. It's not really that big of a deal. Okay, so now let's go ahead and see what this looks like graphically. Graph both of the inequalities on the same number line. X is greater than or equal to 0. Well, since it's greater than or equal to, we're going to have a solid dot, and greater than would go to the right. Or x is less than -3. Open circle on -3. We want numbers that are less than, which would go to the left. Notice that a solution would just be in one or the other shaded areas. It cannot be in both at the same time. But if you look at number 2, x is greater than -2, open circle, greater numbers are to the right. Less than or equal to 1. So we have a solid circle on 1, less than would go to the left, and if you continued your shading for infinity in both directions, you see that they only overlap here in between. So any number in between there would be a solution to that inequality. So for ors, they're going to go in opposite direction. For and, they're going to overlap. So write two inequalities for each number line. For this one, we have x is greater than -4. For this one, we have x is less than or equal to 3. Because we want the shading here to go to the right, we want the shading here to go to the left. So that's how we got our signs there. Because they come together and overlap, this is an and problem. Because you can pick a number that meets both of the inequalities. X is greater than -4 and x is less than 3. Because it's an and problem, we can write it as a compound inequality like this. X is less than or equal to 3. And if we take this and we flip-flop it, because we want the x now on the right-hand side, we still want the big part of the sign, or the open part of the mouth, towards the x, so we would have an inequality like this. So if you read it, it would still say x is less than or equal to 3, but x is greater than, because the big part of the mouth is open towards the x, -4. Okay, so for a compound inequality that goes in opposite directions, we know that this is going to be an or. For the right one, we have greater than because it's going to the right, so x is greater than 0. This one is going to the left, so that is going to be less than -2. And that's all you could do, because it's an or. It means one or the other. You do not write those together. Solve and graph the inequalities. Or means that they should go in opposite directions, and we're going to solve each one of these just like we would any other inequality. So for the first one, I'm going to subtract 3 from both sides, and I get 2x is less than 6. If I divide by 2, I get x is less than 3. That's one part of it. For the second one, we're going to add 6 to both sides. We're going to divide by 3. We have x is less than 3, or x is greater than 6. So less than 3, greater than 6. And you can see they do indeed go in opposite directions. Number 2 would be very, very similar and look the same way. Let's look at 3. This is written together. This means that this is an and statement, so they will overlap when we solve. We want to get this x by itself, so we're going to have to solve this and get rid of that 5. So we're going to subtract 5 to get x by itself, which means we have to subtract 5 here and here. So there's 3 pieces to this problem: the left, the middle, and the right. So we get -3 less than x less than 4. So if we put -3 and we put 4, we want x is less than 4, but we want x is greater than -3, and they overlap in the middle. Number 4. Again, we want this middle piece to be isolated. So we are going to subtract 4, and we get 6 is less than or equal to -2y is less than 20. We are going to divide everything by a -2. And when you do that, make sure you have to flip these signs. So be careful when you're placing these on the number line. -10, -3, -10 is more negative, okay? And if we want y's are greater than -10, and y's are less than or equal to -3, we're going to have a solid, and then they shade together because it is an AND problem.